Hello students, welcome to our channel. Today we are going to study Light chapter class 10 science. Here we will deal with the topic refraction of light. So what is light? Light is a form of energy that produces the sensation of vision, and we know that it always moves in a rectilinear propagation. What is rectilinear? When it moves in a line. You see that if there is any space from where the sunlight can come, so it always moves in a line. It means it follow a straight line. So light is traveling in a straight line. Here we will mainly discuss about reflection. In the previous videos you have studied reflection. Reflection, you see that when incident ray incident on any surface, then it get reflected in the same medium. Incident ray, and this is QR, which is reflected ray. Here we have a normal. This normal, it is perpendicular to the surface. Here the angle which is incident ray with normal, that is called angle of incidence. Another angle, that is reflected ray with normal, that is reflected angle, angle of reflection. And what we observe, angle of incidence, that is equals to angle of reflection. Now let's study refraction of light. Refraction of light, when change in the direction of propagation of a ray of light, when it travel obliquely from one medium to another transparent medium, it is called refraction. Change in the direction of propagation of a ray of light. When a ray of light strike any medium and then it travel from one medium to another, that is called refraction. On the opposite, if it is the reflection, that is reflected in the same medium. Here it is moving from one medium to another medium. Let's consider here A, B, C, D, a glass slab. One medium which is outside the slab, that is air. Another, that is glass, which is a denser medium. Air, we know it is a rarer medium. So here the incident ray, when it strike AB, what do you observe? When it moves from rarer to denser, instead of moving to the straight line, it bends. What do you observe? That when it is moving from rarer to denser, it bends. And how it bends? It bends toward the normal. Right? You see here, this is normal, so it is moving toward the normal. Now this is denser medium and another one, that is rarer. So here, this angle, which is from this to this, it moves toward the normal. Now QR, it's an incident ray. We have drawn the here a normal. Now glass to air means denser to rarer. Instead of moving to the straight line, what do you observe? Now, what do you say? From denser to rarer, it moves away from the normal, right? So this is emergent ray. Emergent ray. From this rarer to denser, it bend toward the normal, and from denser to rarer medium, what do we observe? That it bends away from the normal. Denser to rarer, away from the normal. Now, here, incident ray with normal, that will make an angle I, angle of incidence. Refracted ray with this, refracted ray with this, that is called R. Another one, that is E. This is called emergent angle. Let us understand why does the ray of light bend. Here, when you are moving on any road, right? So what do you observe? It bends to left or right. So here, when speed is more, that side, here it's this side, it is speed is less. Now again, it moves toward this. So this is the direction, this is normal. Now it bends toward the normal. What do you observe? When the speed is less, it bends toward it. So tractor bend toward the normal as its velocity decreases. As the velocity decreases, it's bend toward the normal. So light bends toward the normal. as its velocity decreases. Same here, if you take an interactor, any vehicle, this left side, this right side, now its speed is same. Here, conclusion, rarer to denser toward the normal, denser to rarer away from the normal. Light travels straight, no deviation. If it is moving straight, there is a no deviation. What happens when it moves from rarer to denser? Like this air, this is rarer, water, this is denser. Now here, a light that incident on the surface, it's a normal angle of incidence. Instead of moving to the straight line, straight path, it moves, bends toward the normal. It bends toward the normal. Velocity decreases. So what do you observe here? That instead of air, the velocity of light decreases in glass. Next, denser to rarer, we are taking water, air. Now, light is moving from water to air. So instead of moving to the straight path, what do you observe? As it moving from denser to air, it moves away from the normal. This is angle of incidence, this is angle of reflection. It bends away from the normal. From here we say velocity increases. Right? In the water, the velocity will be less, and here in air, velocity increases. Along the normal, if you will see, now is it moving in a straight line? Yes. So if it is moving along the normal, what we see, it passes undeviated. There is no change in the direction of the light. So here velocity decreases. Now let's see which time. Here, if a ray of light strike the glass slab at 30°, what is the angle of incidence? Here, what do you observe? That it strike the glass slab at 30. So here the angle of incidence, that is equals to 60. Now if a ray of light strike the glass slab normally means same. What is the angle of incidence? So here we say angle of incidence, that equal to 0. If ray of light strike the glass slab at 30°, what is the angle of emergent? That is equals to 60. Now here, a ray of light strike a glass slab at angle of 50° with the normal. What is the angle of incidence? That is 50. Now a ray of light get deviated when it passes obliquely from one medium to another, because why there is a bending? Why it deviated? Because of change in the speed of light. Rakesh performed the experiment of tracing the path of a ray of light passing through a rectangular glass slab for different angle of incidence. He observed in all the cases, what he observed? That angle of incidence that is greater than R. In the refraction, we are not having angle of incidence equal to angle of refraction, but angle of incidence that is equal to angle of emergent. Now, what is refraction? We say it is a change in the direction of propagation of ray of light when it travels obliquely from one medium to another transparent medium. When a ray move from one medium to another, what we observe? That it change its path. From this PQ, instead of moving to Q, like in the same straight path, it moves to QR. Along QR, it moves toward the normal. So here PQ, that is incident ray. This blue color line, this is our normal. This ray, it is moving in air, that is a rarer medium. This ABCD glass slab, that is a denser medium. And here what we observe, QR, which get refracted, not reflected. Reflected means it moves to the same medium, but refracted means it bends. It bends and it moves into the another medium, right? Here, law of reflection, angle of incidence, sorry. Here, the incident ray, refracted ray are normal to the interference of a two transmitted medium at the point of incidence all lie in the same plane. Incident ray, refracted ray and normal. These all lie in the same plane. Incident ray PQ, refracted ray QR, and here we say normal. So they are in the same plane. The ratio of sine of angle of incidence to the sine of angle of refraction is constant. We observe sine of angle of incidence, which is I, sine I, to the sine of angle of refraction, that is sine R, it is equals to constant. Implies it is refractive index, right? We called it M. Now, let's consider here eyes. We consider normal here. A ray of light get incident on it, and then what we observe that it changes its medium, it get refracted. So here sin I by sin R, this is equal to 1.31. What is this 1.31? This is called refractive index 1.31. Again, take another example, diamond. Here also we consider normal, a ray of light incident on it. Now it again get refracted as it moves from rarer to denser. We observe it is sin I by sin R, which is equals to 2.42. What is this 2.42? That is refractive index. Now let's do one experiment. We are taking any glass tub, with that a pencil. Pencils appear to be broken in a beaker with the water. But you observe that when you see this pencil and this beaker filled with water, you see that now it's not looking as normal as it was. It observed that it appears to be broken, right? That it appear that it's here from this point it bends. So what you observe, that angle of incidence here, which is making an image, that is another place, right? So it is called apparent position. And what is this? This is the actual position. So here, why? What's the reason? Because of the refraction of light coming from the part of pencil that is underwater. The pencil appear bent. Now, what is refractive index? We have a medium 1, another medium 2. We know that sin I by sin R, it is equals to a refractive index. Let's represent this refractive index as n. N2, N21. What do you mean by this N21? This is here V1 by V2. It is the ratio of, you can say, velocity of light in medium 1 to the velocity of light in medium 2. Now, what we are doing? We are taking the rays in opposite direction, like from medium 2 to medium 1. So what is the refractive index of N12? That is V2 divided by V1, right? We take it in opposite ratio. So here these two are reciprocal of each other. We can say N21 or N12. These are V1 by V2 and this is reciprocal, that is V2 by V1, right? Now N21 we can say here it is 1 by N12. Now let's understand absolute refractive index of some material media. So here absolute refractive index means first medium, this is vacuum. Absolute refractive means always the first medium, that is vacuum. So now we are finding the absolute refractive index of air from vacuum to air, right? Now how it's moved? That it moves from vacuum to air and the absolute refractive index of air is 1.0003. Another one, vacuum to ice. So here let's take the incident ray and then it get refracted. So here what do you observe? The absolute refractive index of ice, that is 1.31. Another example, vacuum with the water. What do you observe? That this refractive index of water, it is 1.33. So you can learn this values 1.0003. For ice it is 1.31. For water it is 1.33. For crown glass The value of refractive index is 1.52. For rock salt, it is here 1.54. For diamond, we have here 2.42. So these all are the absolute refractive index of different material. But you observe that the always this here always light is traveling from vacuum to that material. Conclusion: refractive index increases, the bending capacity increases. So here you observe this here angle of incidence, it's same, but the refractive angle that is different. So here you see the bending capacity that is increasing. So now let's take example. The refractive index of diamond is 2.42, right? What is the meaning of this statement? So from here, what do you observe? Refractive index is 2.42. What is the meaning of this? That here speed of light in a diamond will reduce by a factor of 2.42. Why it is so? Because we are saying refractive index, it is the ratio of that. So we can say that it reduces from this diamond to the air, right? Now, framing the formula for refractive index. Absolute refractive index of air, we are saying it is an AB. AB means refractive index of air with respect to vacuum. So here what we are taking, we always take the velocity of the second one, right? So velocity of vacuum by velocity of light in air. It's a velocity of light in a boat, right? So it is vacuum by air. Now I's by A, just you please tell me that it is the ratio of volume of velocity of light in air to the velocity of light in ice. Next, we can find here V, V and VG. You can write here it is refractive index of glass. रिफ्रैक्टिव इंडेक्स ऑफ ग्लास, ग्लास का फाइंड आउट कर रहे हैं, डिवाइड बाय दिस. सो इम्प्लाइज वी आर finding here refractive index of glass with respect to vacuum, right? Or you can simply say it is absolute refractive index of glass, right? Now find this refractive index of water with respect to air. We need to find out the refractive index of water with respect to air. So first we write down velocity of air divided by velocity of water, right? It's velocity of air by velocity of water. Now you can find out refractive index oil air means what you are going to find out. We are finding the refractive index of oil with respect to air, which is equals to velocity of light in air by velocity of light in oil. So here we are refractive index of oil with respect to air. Now, what is the formula we learned? N21, that is equals to velocity of one medium to the velocity of second medium. N21, what it means? It is the reciprocal of, we can say, the refractive index of 1 with respect to 2, right? V1, that is velocity of light in first medium. V2, velocity of light in second medium. Let's understand some important point. If the first medium is not mentioned, take the first medium as air always. Second, if the first medium is a vacuum, the refractive index of second medium, it is called absolute refractive index. What we are saying, if the one medium, the first medium, that is vacuum, we always consider it as absolute refractive index. For solving numericals, velocity of light in air, that equals to velocity of light in vacuum. This is always equals to 3 into 10 to the power 8 meter per second. So n, it is the refractive index and which has no unit. Why it is having no unit? Because this is having the same quantity v1 by v2. This is also velocity, another one that is also velocity. Now let's understand the numerical here. Light enter into a glass plate having absolute refractive index 1.50. What is the speed of light in glass here? Here it's given speed of light in vacuum, that is 3 into 10 to the power 8 meter per second. Velocity of light in vacuum, that is VV, it is 3 into 10 to the power 8 meter per second. Absolute refractive index, it is given NGV, right? It's 1.50. We need to find out the speed of light. So here we are having the velocity of light in glass. This is the ratio V, velocity of light in vacuum, Vg, velocity of light in glass, and this is refractive index of glass with respect to vacuum. We can say it is absolute refractive index of glass. So NGV, that is VV divided by VG. We need to find out the velocity of light in glass. Take this denominator that side and this value on the downside. So it is equals to 3 into 10 to the power 8 by 1.50. Let's find it. It is 2 into 10 to the power 8 meter per second. Here you can solve. 3 with this we cancel out. It is equal to 5, right? 1 2 zeros, it will move upward, and then we divide and we get here 2 into 10 to the power 8. Now the speed of light in glass is 2 into 10 to the power 8. Refractive index of water, it is 4 by 3. Speed of light in air, that is 3 into 10 to the power 8 meter per second. Find the speed of light in water. So here refractive index of water, that is 4 by 3. Speed of light in air, that is 3 into 10 to the power 8. We know refractive index, it is equals to here velocity of light in air by velocity of light in water. Now we need to find out speed of light in water. So this value. So take the denominator upside. We have here this, right? It's 4 by 3 into equal to 3 into 10 to the power 8 by velocity of light in water. It is equals to 3 into 10 to the power 8. Take this 4 downside and 3 upside. So here what we got, it is 9 into 10 to the power 8 by 4. It is equals to 2.25 into 10 to the power 8 meter per second. Now if the refractive index of water for light going from air to water, it is 1.33, then what will be the refractive index of light going from water to air? Here, refractive index of water with respect to air, that is 1.33. To find refractive index of air with respect to water, what we need to do? Let's take the formula. We are taking opposite, water with respect to air and air with respect to water. So no need of finding the velocity of different quantity. We always take the formula, that is N of AW, that is equals to 1 by refractive index of water with respect to air. So here 1 by 1.33, that is equal to 0.75. So here what you observe, refractive index of air with respect to water, that is 0.75. Now let's take the another numerical, the refractive index of kerosene, turpentine, turpine all we say, and water, that is given. These all values are given. In which of the material does the light travel fastest? We need to find out that in which material light's velocity will be more. So here we know refractive index, that is speed of light in air by speed of light in medium, right? And we know the formula of speed of light in air, that is 3 into 10 to the power 8, right? It is obvious that above relation, that speed of light will be the maximum in that medium which has the lowest refractive index. Take this side, that side, right? So we have the lowest refractive index, we have a speed of light in medium that will be more. So which one have refractive index less here? 1.44, 1.47, 1.33. 1.33. Here we can say the speed of light in that medium will be more, right? So here out of this we say that water has a less refractive index, means here the light will travel with the more speed. Now question is, in which of the following given media light moves the fastest? Medium, it's given water, ice, alcohol. Refractive index, it's given 1.33, 1.31, 1.36. Using above the table, calculate the velocity of light in water. Right? So here light travel fastest through ice. Why? Yeah, we know the reason, that if we have less refractive index, the lowest one, there the light travel fastest. So now velocity of light in water, that is equal to velocity of light in air by refractive index of water. It's 3 into 10 to the power 8 by 1.33. So it's 2.25 into 10 to the power 8. Now next question is the path of light passing from air to different media A, B and C for a given angle of incidence is shown. Study the diagram and answer the following. Here you see that this angle making incident ray making an angle of 60 degree. This here it is making an angle of 30 degree. Here 60, here 45, here 60 and here another one 40. So which of the media A, B, C has a maximum optical density? Through which of the three media will the speed of light be maximum? Will the light traveling from A to B bend toward or away from the normal? So here we see that sine 30 is less than sine 40. Sine 40 is less than sine 45. So here we say that where it bend more, the density is more, right? So refractive index, we can say the diffractive index of A is greater than diffractive index of C and greater than diffractive index of B, right? So medium A has a maximum optical density, right? Another one, through which of these three media will the speed of light be maximum? So here we know that the lowest value of refractive index will be having speed of light more. So here we say which one is the lowest one? It's here B, right? Which one is here lowest one? B. So here the light of speed of light that will be maximum. Another one, will the light traveling from A to B bend toward or away from the normal? So here we say refractive index of A is greater than refractive index of B. So light traveling from A to B will bend away from the normal. Now this is all about. We will continue our lecture lens topic in the another lecture. Till then, take care. Bye bye. If you like the video, please share it with your friends. Subscribe the channel so that you will get the new notification. Thank you.